All right. So you have to know what the limiting reactant is before you can calculate what the theoretical yield is. Now, the limiting reactant is a chemical species, okay? In this lab we just recently did, you were reacting lead to nitrate, which we dissolved, with potassium iodide, which you dissolved, and we performed a chemical reaction by mixing those two solutions together, and we got lead to iodide, which turned out to be a solid, a yellow solid, which you collected through filtration. And we also had potassium nitrate, which remained in the solution, and that's what, when you filtered, the water and the potassium nitrate ended up in the filter flask, the Erlenmeyer filter flask, the sodium flask.
Why is that stuff so hard to get up off the table, the yellow stuff?
Because it's really, really tiny. Little tiny powder, you know, it's just hard to get it up. And you have to use soap and water and work at it.
It's like paint, right?
It actually has been used as a paint pigment. It's not a good paint pigment to use because it's got lead in it. So, you know, I don't know if you know about the dangers of lead paint, but that's a problem. All right. Lead paint, what happens is when you paint, for a long time paint had lead in it. But like all paints, it eventually will peel off and flake after it gets old. Turns out that children and pets and things will ingest that, and it gets in your liver. It causes brain damage. It causes liver damage. It causes all kinds of problems. Heavy metals are not something you want to get in your body. I mean, you have to have a very, very tiny, tiny amount of lead ion in your body, but too much causes lots and lots of problems. Did you have a question? Okay. All right, then we balanced the equation, and we ended up with this. And then you had to figure out what your limiting reactant was. Every lab group's limiting reactant is different. So if you don't correctly identify your limiting reactant, you won't be able to find what the correct, if you don't correctly identify it, then you won't be able to find the theoretical yield properly. Okay? So, I told you that you need to go back and check and make sure. And I tried to help a few of you yesterday before we ran out of time, and I didn't see anybody else come and get any help. So if you haven't figured out your correct theoretical limiting reactant and haven't gotten help, then your theoretical yield is going to be wrong, and your percentage yield is going to be wrong. Okay? So if you haven't fixed that, you have even more work to do now. Okay? Because you've got to turn all this in tomorrow.
Is the limiting reactant a number?
The limiting reactant is a species. It's either this or this. These are the two reactants in your chemical equation. Okay, so it's either going to be the species lead nitrate or the species potassium iodide. All right? And these two over here are your products, but this is the product that we collected. Okay, because it was a solid that we filtered out. Okay? So you have to identify which one of these is the limiting reactant. By definition, I think I gave you this definition. The limiting reactant is the chemical that runs out first in the reaction and prevents the reaction from moving forward. Okay? You want me to write it down for you?
Yeah.
A good example of limiting reactants is how you go about putting out a fire. when you're burning something, you know from our the last unit when we're talking about combustion reactions, you have to have two things to burn something. You have to have a fuel, and you have to have oxygen. And how do you stop a fire? Deprive it of oxygen, and that makes the oxygen the limiting reactant. So when you put water on a fire, you keep oxygen from getting to the fuel, and that's what puts out the fire. The oxygen then is the limiting reactant. Yes.
But it's oxygen and water, though, right?
What now?
But it's oxygen and water.
Yes, but except for a very few highly reactive metals, fuels don't react with the oxygen in water. Yes.
Like, I know water can put out a fire, but then, like, how does it make it worse?
How does it make it what? Worse? Yeah. If I have, let's say, a container that has a fuel like gasoline, and I take I put it on fire. Okay, so I've got this container full of gasoline. It's on fire, and I take and pour water into it in a stream, like out of a water hose. What happens is the water doesn't cover the whole top. It just goes through one little place in the top where the gasoline is. The gasoline then is lifted up and pushed out, and you get a bigger fire. Okay? The way that you have to stop the fire is to make sure that the whole area where the fire is it has water on it at the same time. So something that you wouldn't know unless you probably were a firefighter is firefighters don't spray a single stream of water into a fire. They spray a big spray of it. It's a big spray like this, and that's what prevents the oxygen from getting to the fire.
Fires, like, I know, like, they're caused by, like, cigarettes, like, left out, or, like...
Can?
Yeah.
Could?
Like, does, like, the sun, if it's, like, really hot, would it just, like, light a tree on fire?
No. The sun won't light a tree on fire unless global warming gets a whole lot worse than we expect it to get. But there are certain chemicals in certain conditions you can have a spontaneous reaction. Okay, but that's another subject for another day. But not a tree.
You believe in global warming?
It's not a matter of believing in global warming.
Yeah,
that's like, do you believe in God?
I asked that because there's a lot of politicians that say that it doesn't even exist.
Well, I think the measurements that have been made clearly show we are going through a period of global warming. Now you can argue, but that's like arguing that your desk doesn't exist. The numbers are there. Okay. The only reasonable question, in my opinion, is the global warming we're going through something that's part of a natural cycle, or is it partly to do or greatly to do from our human influence on the environment? That is, we're putting a lot of CO2 in the atmosphere and so forth. Okay, and in science we don't prove things, right? We talked about that in Unit 1. Science doesn't prove things. What we do is we offer support for models, and if that model is accepted, we get a theory. Okay? There is lots and lots of support for that theory that human influence is making global warming worse. Whether nature has something to do with it or not, that's not really clear. What is clear is if you look at the evidence in our geologic record on the Earth, I mean, this is where a lot of research has been done about using ice cores and various things. You find that at times when the Earth's temperature increased, there were corresponding increases in CO2 levels. And we know that through study of chemicals like CO2, that's quite possible that CO2 can cause that. I mean, it does cause that. Now, there's a lot of things you have to connect together to come up with a viable theory. I think this theory is very viable. Now, so it's not a matter of belief, it's a matter of being willing to accept facts and theories that are substantial. Okay? I mean, you can put your head in the sand and not look at things, but that's like saying,
Are you, like, a creative?
Okay, can we get back? I know we're getting off the subject here, okay? And y'all, and I understand there's a reasonable There's a reason why you guys ask these questions in the sequence you ask them, but we do need to do this first.
Are you like a scientist?
You were a scientist,
I know.
okay? Of course.
Okay.
All right? All right, now, let's get back to this. Once you figure out what your limiting reactant is, then you're ready to proceed. So until you know which one of these two is your limiting reactant, you're not even ready to start this calculation. Of course, your limiting reactant might be lead nitrate, or your limiting reactant might be potassium iodide. And each lab group's limiting reactant might be different, or is different, possibly, most likely is different. Okay? Of course, I mean, statistically, about half of you are going to have this limiting reactant, the other half are going to have this. But you have to have the numbers to verify and support that conclusion. All right? Now, what I can show you today is how to do the calculations for figuring out what your theoretical yield is without actually giving you a mathematical answer, because I don't have your mathematical number to start with. This is what we did yesterday. Yes?
When we get done, can we like do one and go through all of this? Cause I like we need to do one where we gotta do the product, the atom inventory.
Sure.
All that.
Sure. I'll make up some numbers. Listen to me. I will make up some numbers, and from those made up numbers, I will show you how to do the math. Okay?
Okay.
Well, listen, I can't tell you how many times students have said, where'd those numbers come from? I made them up. Okay?
I
All right.
wanna do one of those.
So, big if your limiting reactant is lead nitrate, I want to start with that one. Okay? So that's only if you have correctly identified lead nitrate as your limiting reactant. Have you exchanged your paper now?